In this video, I will go through 3 real-world modeling examples of equations or inequalities. First, what I'm going to do is find my starting point. Second, I'll find my rate of change. That's also known as your slope. Third, what I'm going to do is write my equation. And fourth, look for my inequality word to write it as an inequality instead of an equation. So you'll notice that A, this first side here on the left will be our equations, and B, we're going to change them to inequalities. And we're only going to solve the inequality ones. So for my first example, it says you're going to the amusement park for the day. The amusement park charges $7 for admission and $1.50 per ride. So part A says that you have $25 to spend. Write an equation to find X, the number of rides that you can go on. So first what I want to do is notice that they told me that I have $7 for admission, so I have to pay a $7 fee. Plus, if I want to go on any rides, it's $1.50 per X number of rides. So that's why I'm going to put that X here, because per ride, my number of rides is X. Now, an equation means you have an equal sign. And my equal sign will be, if I have $25 to spend, how many rides can I go on if I spend all of my $25? But now look what's going to change over here, because it says now the word inequality, and my phrase for my inequality says the most. The most I can spend is 25. And here's why these inequalities are more real world, is because even though you have $25, you don't have to spend all $25. So you may want to spend a little less than that and then, keep some of the change for another rainy day. So if I change my equation to instead say the most I can spend is 25, I would say 7 plus $1.50 per number of rides. We can spend up to $25, meaning less than or equal to $25. And now what I'm going to do is solve for the number of rides that we can go on. So I'm going to subtract 7 from both sides, and then I'll have $1.50 per ride is less than or equal to $18. And now when I divide by $1.50, so 18 divided by $1.50 will give me an X value less than or equal to 12 rides. So I can ride up to 12 rides. Or less, because we don't have to spend all of our money. Now for the second example, my scenario changes, and it says Joe works at the ticket booth for a local movie theater. The movie theater has already sold $500 worth of tickets during a pre-sale event, but they're going to sell tickets at the window for $10 each. Here's letter C. If the movie theater earns $1,000, how many tickets did they sell? And we are going to write an equation to solve for X number of tickets sold. So there have already been $500 worth of tickets sold, plus they're going to sell additional tickets for $10 each. How many tickets did they sell if they earned $1,000 for the night? Now what's going to change here, if I do an inequality instead, I'm going to look for my word phrase that says what I'm going to change my equal sign to. So if they want to make at least $1,000. Oh, if we could just make $1,000 or more, that would be a good night. So what symbol would we replace our equal sign with if we want to make at least $1,000? So I'm going to have 500 for my pre-sale plus 10x. Now instead of an equal sign, we want to make more than or equal to the $1,000. Now I'm going to solve for my X number of tickets that were sold. I'm going to subtract 500 to each side of my inequality. Then I will have 10x is greater than or equal to 500. And 500 divided by 10 is going to be 50. 50 tickets. So we can sell 50 tickets or more. Now for my very last example on this page, again, my scenario will change to this. Casey is buying pizza for her family. It costs $12 plus 50 cents for each topping, and taxes included in that $12. For letter E, it says you have $22 to spend on that pizza. Write an equation, so this is going to have an equal sign, that can represent X number of toppings for that pizza. So if you have $22 to spend, I need to take into account that I have $12 for just the cost of the pizza without toppings, plus 50 cents per topping, and we can spend all of our $22, so if I have an equation, I'm going to say equals 22. So $12 for the pizza, 50 cents per topping to equal my $22 to spend. But if I use an inequality and I say the maximum number of toppings, so maybe she doesn't want to spend all $22, how many toppings can she get maximum would be less than or equal to $22. So maybe she doesn't have to spend all of that $22. So to solve, I'm going to subtract 12 on both sides, and I'm left with 50 cents per topping will now be less than or equal to $10. And if I divide by 50 cents, I'm going to get X is less than or equal to 20 toppings. So she can purchase, or I should say put on her pizza, she can put 20 toppings or less on the pizza.